So I haven't read this in advance. Yeah, tell me. So what did he do next with the prisms? Come on. He's shedding a whole new light on. Is this why you were giddy?
I was genuinely excited about this, and you always have to turn it into some awful sexual innuendo-ridden film.
Come on.
TheScienceShed! We're in the TheScienceShed! TheScienceShed! We're in the TheScienceShed! Come on, Steve.
Bunsen.
Burner.
Dolly.
Machine.
Internal.
Combustion.
Why do we need
Steam.
Petri?
Dishes.
Austin.
Base.
Isaac.
Newton.
Transplanting.
Nick, we're in the Science Shed.
What?
We're in the Science Shed.
Where's that?
It's a shed of the mind.
No, it's not. It's
It
a
is.
real shed.
Of
Look
course it
around
is. I was
you.
just joking. We're in the shed. Do you know how we're in the shed? Because we've got loads of equipment here. We've got a
Yeah,
saw.
look at this piece of equipment here. I don't know what it is. It's one of those things that you find in the drawer. You're never sure what it does.
Yeah.
It's kind of like metallic with a hook on.
There's a real risk of what do they call it when you fall on a nail? What's the bacterial infection you get?
Well, tetanus.
Tetanus.
Yeah.
There's a real risk of tetanus in the
Well, I've
shed.
had my jabs.
I haven't. I should do that.
Oh, you're risking it there, aren't you, Steve?
Science of the past. Pulled any month across and pulled in your glass. I didn't have the internet, which is a Game of Thrones, but still I had some fun saying shit like telephone.
Nick,
All right, Steve.
how you doing?
Yeah.
So, remember when you were a kid, did you ever have top trumps?
Oh yeah, I love top trumps.
Yeah.
My favourite, most played pack was one of boats, different sorts of boats.
But I had the car one, the supercar one. That was good.
Yeah,
I
I
like
don't think
that.
I had that one.
That was good. And there was the Marvel ones as well.
No, I never had them.
If you
You're
had-
a bit younger than me, though, aren't you?
I am, yeah. Did you? If you had to make a a scientist top trumps, who would be the best? You know, in top trumps, there's always one
It'd be
card.
Albert Einstein, wouldn't it? Obviously.
Do you think?
Well, it'd be Albert Einstein, Isaac Newton. You might have like
that's the one.
Wolfgang
the Godfather
Pauli.
of gravity, the Maestro of mass. I think it's got to be Isaac Newton.
Yeah, but Einstein was more of a paradigm shift when Einstein discovered all of these.
I'm about to rock your world with that not
Ooh,
being true.
okay, I'm interested.
So I have a paper here, which I
Yes.
think I'm gonna break this down into separate. We can come back to this in different podcasts. I'm just going to introduce it to you. So I found this paper from 1671
Okay.
that Isaac Newton wrote to the Royal Society, and in it, like I read this the other day, and I was giddy with how beautiful it is.
Oh my God.
I can't do it justice on the podcast by only doing it in one go. So we're going to break it down.
It's amazing that you can get giddy reading a paper from 1671.
But I am a bit weird.
I can vouch for that.
That's true. Right. So this is so I'll read you. I'm just going to read a little bit, and we're going to stop it now. But it's a letter. So I'll read you to this paper. It says a letter of Mr. Isaac Newton, Professor of Mathematics in the University of Cambridge, containing his new theory about light and colours.
All right.
Sent by the author to the publisher to Cambridge, February the 6th, 1671.
So this was all to do with stuff about him splitting white light and finding that it's lots of colours with the prisms and all that. It's a famous story, isn't it?
Yeah. So so this is where all those stories come from, right? I've got the raw.
Yeah.
I'm going to read you a little bit, and we're going to go through it each week because it's when you go through it, it's incredible.
Am I going to understand it? Because this is all old school English, and it's going to be very difficult to get my head around.
I'll do it in bits, right?
I think,
so
yeah,
let's start. So
one sentence.
So yeah. So basically,
is it about like gravity then?
it's not about gravity.
Oh, right.
It's about. But you're right. It's about colours. So you have to remember the time, right? 1670. So actually, this was 1666 where he did these experiments, right?
This was Great Fire of London time.
In fact, halfway through it, I'll tell you, he has to. Oh, actually, I won't ruin it for that. It's good. Yeah. But yeah, so to even think about the world, then, right? So he's asking basic questions about what is color, right, and what is light, and to even think about these things was quite heretical, right? To actually question the where the heavens are, those kind of things.
It
And
was
that's
the Enlightenment.
indeed.
Did they know it was the Enlightenment?
At the time,
Probably not. Didn't
no.
they?
It's only in hindsight you get that.
What age do you think we're living in now?
technological revolution, I reckon people will probably look back on it as.
Not the Trump.
The post-truth
Trump.
Post-truth era.
Yeah.
Yeah. Anyway, first paragraph. To perform my late promise to you, I shall...
Sounds like a love letter.
I shall, without further ceremony, acquaint you that in the beginning of the year 1666, at which time I had applied myself to the grinding of optical glasses of other figures than spherical.
He was actually very competent lens grinder.
Well, this is how we know that, right? That I procured a triangular glass prism.
He got this from the fair on there was some fair with some. Am I allowed to say gypsies these days?
Probably not. Travellers.
There was a traveller. Do you think they called them a traveller community? I don't think they did. They were gypsies.
Right. Okay.
He bought it off a gypsy woman.
So yeah, you have to remember when people were interested in like astronomy at that point, you didn't just go and buy a telescope. You had to go and get a bit of glass and grind it down, right?
So buying a prism would have been like the equivalent of like going in one of those magic sort of new age shops when you buy some fucking wind chimes.
And a dream catcher and a crystal, some rose quartz.
I'm going out to procure myself a prism from the gypsy.
Yeah. So this is his performing his late promise to us, to try therewith the celebrated phenomena of colours, and in hitherto having darkened my chamber and made a small hole in my window thus.
He was actually helped by he had a servant.
Oh really? Like a Smithers.
And it was like a Smithers because it's thought that Isaac Newton was gay.
Right. Okay.
Yeah, he was kind of he had this. Italian gay squeeze for a long time.
Right.
But obviously it was difficult to be gay in 1760.
Yeah,
1771.
Yeah, that's not a good time.
But yeah, he had an assistant who looked at and prepared all of these experiments for him, blacked out the room and everything. So you imagine two of them in the room, a bit of sexual tension going on. Get the prism out. Can you reach for the prism?
Yes, I love it when you talk dirty.
Are you talking about me now?
No.
Oh, right.
So I placed my prism at his entrance.
So I haven't read this in advance. Tell me. So what did he do next with the prism? Come on. He's shedding a whole new light on. Is this why you were giddy?
I was genuinely excited about this, and you always have to turn it into some awful sexual innuendo-ridden filth.
Come on, bring it on.
Anyway, so I placed my prism at his entrance, that it might thereby refract onto the opposite wall. It was first a very pleasing divergement to view the vivid and intense colours produced thereby.
People knew about this because they were hanging over the New Age, and that's why they sold the prisms, wasn't it?
Yeah.
To do that. Yeah.
But after a while, applying myself to consider the circumstancy, I became surprised to see them in an oblong form, which, according to the received laws of refraction, I expected them to have been circular. Right. So he's just basically looking at a rainbow, is what he's doing.
Yeah,
right?
yeah.
And then he goes through this.
Anyone that's got a few. I was going to say, anyone that's got a chandelier like me.
yeah, I've been to your house. I haven't seen.
We bought an extremely tacky thing, but if when light shines through that stuff, you can always see them. I mean, it's crystals of stuff.
But you have to remember, like, glass is a relatively exotic material at this time, right?
So,
and actually, so in
shaped glass,
particularly,
probably not easy to come across.
No, you have to grind. And in fact, he talks about.
You have to make the surfaces very clear as well.
So he says exactly that, right? So he's looking at this rainbow, and he's freaking out that it's not round, and the fact it's oblong. He's comparing the length of the coloured spectrum with its breadth. I found it about 5 times greater, a disproportion to the extravagance that it excited me to more than ordinary curiosity of examining from whence it might proceed.
See, these types of sentences in 1671.
That's a hard one. But so then I suspected whether any unevenness in the glass or other contingent irregularity might affect the colours thus. So he did exactly as you suggested.
Yeah.
So he goes through these things, right? And so we'll come back to what he does. But I just want to say that the kind of if you ever read like Origin of the Species or something like that, or any of those kind of old big scientific ideas, there's bits of it that are a bit wrong. You go through it and you're like, that's close, but the idea is so powerful that it persists, right? And we'll go through this in a separate podcast. But like, what's amazing about this is everything is on point. he gets everything right. And in this article, he talks about refraction, what colors are, right? The idea that they must be composed of separate colors that when they come together can reform white light. He talks about how they're different and how they bend.
I mean, that was his experimentum crucius, which was when.
But that's in this paper.
Oh, is it really? So he split them up and then he put them back together again. That was a demonstration. Yeah.
Exactly, but then he did it even further. He also talks about how we perceive light, like red, green, and blue. He doesn't call it this, right? But the idea being that if you take red and green light and you mix it together, it goes yellow. And he says that's not really yellow light. The only really yellow light is the light that comes from white light as it goes through a prism, right? So he talks about that. He then talks about the importance of chromatic aberration, right? So he talks about how that light must be focused because it's got a different wavelength, it's focused through the prism to a different amount.
So chromatic aberration is basically if you've got a lens and you're trying to do a microscope experiment, the object might look fuzzy because basically the blue light comes to its focal point at a different point than the red light. So that means that it gets a bit fuzzy.
I mean, you get that. So this is true if you're on your iPhone or something. If you look at a picture, if you zoom right in, sometimes what you sometimes see is particularly the edges of your image. Quite often you'll find that the colours start to split a little bit, right? Yeah. And so all this comes from him just thinking about it, right? So he works out. Then he goes, the telescopes must be rubbish then. But because he's recognised that they're made up of separate wavelengths, that they're going to be focused to a different focal plane, that therefore telescopes don't work. And then he goes, okay, so he makes up a telescope that doesn't require how to solve this problem doesn't require focusing, but he needs a new material. Then he finds that new material, he invents and then makes this new telescope, and then sees the moons of Jupiter with it. He then uses that to build a microscope and to how you might build a better microscope. He then talks about the phenomenon of how a rainbow works based on pure deduction of just the principle of this light bending. He talks about kind of mixtures of colours and things like gold. So like when you look at gold, it's got this doesn't look like any of the primary colours of the rainbow, or any of the colours of the rainbow. How should that happen? Yeah. All of this, in Bad Mouth's Robert Hooke. So Robert Hooke actually makes microscopes. He doesn't even need it. He just thought about it for 2 years and he just beat him to it. Like all of this is an experimentum crucius, which basically he makes a monochromator and then uses that to determine they must be of the ordering of the wavelengths of the light. Does all of that, tells the people at the Royal Society how to do an experiment that they need to do, and if they can't reproduce it, they should come back to Cambridge and he'll show them how it works. And all of this is all just in one paper.
Steve, do you wish you had been assisting?
Oh my God, I've got a bit of a man crush.
Do you wish that he had positioned
his prism,
the prism
near my entrance?
To your entrance?
But yeah, we'll come back to it. But so 1666. So yeah, I'd have him as my top trump of choice. What's your argument?
Well, I've not come pre-prepared because I can't recite papers from.
You can't win.
I mean, Einstein is pretty impressive.
He is.
Because
I'll give you that.
He came up with several ideas. He was known for the photoelectric effect first, wasn't he?
So he published 3 papers in
1905.
The magic year, the golden year they call it, right? So one was on Brownian motion. One was
the
on
annus mirabilis.
Yeah. One was on the photoelectric effect, and one was on specific relativity.
Special relativity.
Sorry, special relativity.
Yeah.
And so like they basically say 2 out of 3 of those definitely deserved a Nobel Prize, and he published all of those without a PhD at 26 when he was doing another job.
Yeah.
It's pretty impressive. Isn't
pretty
it?
Cool.
Yeah, but I think like Newton, when you go through it, and what's so profound about it is just that it's all right, and he's all done it just from thinking about it from a bit of glass he puts on his windowsill.
He did a lot of experiments though.
He did, but it's that kind of deduction that just saying if this is true, therefore this must be true, and this is how that works. Which I think is so profound, and it's really beautiful. And I'm going to show you. We'll talk about it a bit more, but he's my top trump of choice.
Steve, I came across paper.
Excellent, Nick.
Well, I didn't quite come across paper.
Yeah.
I saw something in the news, and it directed me to a paper.
So you came across that paper?
I came across the paper, yes. I had a read of the paper.
Right.
Do you remember we talked a while ago I think it may have been in podcast 4. I'm not totally sure, but it was about chimeras.
Chimeras, yeah. That's like the babies forming with when you can end up having your dad's your uncle or something.
Yeah, exactly.
Yeah.
Your child. Yeah. Let's not go into it. I've done it before.
Yeah.
But anyway, how do you think you might use a chimera to replace your liver when it starts to wear out?
How do you So I suppose can you take so chimeras are basically a mixture of two different species or two different. No, it's the same species but different people.
They're two.
It's the same species but different individuals or different mice or whatever.
Yeah, it's an organism made up of two distinct genetic identities.
That's right. Okay.
So
they've got different DNA.
Cellular genetic entities. So,
right.
Composed of different cell types from a different genetic source.
Okay.
So different.
So could you take a transplant of a liver from a I don't know, a relative or something to trick your body into growing a new liver or something?
Not quite. I'll explain a bit of the background to this.
Yeah.
So there was a story, and people may have seen it. It was about using pigs to grow human organs.
Right.
So one of the kind of like big challenges
Yeah.
in the world is there's not enough organs to go around everybody.
Yeah.
So people die on waiting for a transplant every day.
Yeah.
And it's a lot of people every year. Simply not enough organs to go around. That's why.
There's a
People
list
have been
and committees and things like that.
Yeah, and people have been trying to make it a default situation that after you die, your organs are automatically.
Which is a brilliant idea.
Which I agree with. It's still not the law in this country, though.
Is it the law anywhere?
I don't know. I've got a feeling that they were, in the regional breakdown of the UK. I've got a feeling in Wales maybe that they were starting to implement it.
It does make sense as an opt-out model rather than an opt-in.
I think I've got a feeling in the Netherlands and maybe in Switzerland.
In all those
it's a sensitive.
Scandis. I bet the Scandis do it. They're normally ahead of the curve on these kind of things.
Yeah, although I wouldn't be so sure. I mean, these sorts of things in certain countries that are liberal, you find this would happen.
Yeah.
But I don't know. That's
okay. So anyway,
but anyway, so with these chimeric animals, what you can do is, in short, you've got an embryo from one species.
Yeah.
Into that embryo, you can introduce some cells from a related individual, for instance, and you remember you can come up with an animal which is composed of more than one cell type.
Yeah.
So you can take a brown mouse and you can inject its embryonic cells into a white mouse, and you get a patchy mouse. Because the mouse that's formed...
Like a mouse Dalmatian.
Exactly.
Yeah.
But the mouse is composed of basically maybe its own cells, but also its brother's cells.
Yeah.
So it's kind of like a brother and a brother
Yeah.
type situation. Very weird. So two twins can be meshed together. And this happens in human populations. But it's being used scientifically, right?
Mm.
So what people have found is you can do interspecies chimerism.
That's cool.
It's amazing, and the most.
So typically, normally, I suppose why that's a big deal is if you took like a pig's liver and tried to transplant your body, reject it, right? Because it thinks it's foreign organism, which it is, right?
Yeah.
So what's different? How do you manage to do it? How do you do interspecies organism?
Well,
how is it not rejected by your immune system?
It started off based on experiments on rats and mice.
Okay.
So you can inject rat cells from embryonic cells from a rat. So you grow what are called embryonic stem cells from a rat.
Yeah.
There are lots of different types of pluripotent cells now. Basically, you can think of them as like embryonic-like cells. You can inject them into a mouse embryo.
So what does pluripotent mean?
Pluripotent just means that it's a cell type that can turn into any type of adult cell.
So people would, okay, fine. So this is so depending upon its environment, it could end up being a bone cell or a brain cell or a bit of your liver or whatever.
Yeah, and that's why people are excited about embryonic stem cell research, because if you can grow a load of them in a dish, you could make a load of cells to cure a disease where you've lost a cell type, which is important, like diabetes, you lose a cell type. So if you can make that in a dish, you can replace those cells.
Okay.
One of the big drawbacks one of the limitations with growing tissues is you can't make big lumps of stuff. We just don't have the technology. We don't have the technology to make a lump of liver, for instance.
Yeah.
Because you need a blood vessel network. It's really hard to make a blood vessel network. So this has led to the idea of using chimeras to solve this problem.
We're so rubbish at doing biology, aren't we?
Horrible,
Nature's amazing at it, and we're so rubbish at it.
It's pretty tough, though. It's complicated. You're working, there's billions of years of evolution has led to it.
I know, but when you think about it, like, we spent all this money and all this time and all these people working so hard, and basically all we've done is take some cancerous cells and put them in a dish and they live forever. Right? But there's no... When
Hang a minute, I'm going to tell you about an amazing step forward in a minute that I saw in a paper this week.
All right, do it.
So basically, for the past few years, people have learned how to make interspecies chimeras.
Right.
So what you can do is you can take a mouse embryo, the embryo of a mouse, and you can inject into that embryo rat embryonic cells.
Right. So which the body should reject.
Species, yeah, 2 different species. Nothing to do with rejection.
No, but it should do, right? Typically.
Not before the immune system's formed, because you don't have an immune system.
Right. Okay. So you're doing it in the embryo.
So you've got an embryo.
Sorry, I misunderstood.
No, you've got an embryo of a mouse in a dish.
Yeah.
Think of in vitro fertilization. You grow the embryo in a dish, then you implant it into the woman. That's an embryo. Those embryos you can do in vitro fertilization with a mouse. You can store the embryo. The embryo is in the dish. You can manipulate that embryo. So you can inject cells from a rat's embryo, pretty much, into a mouse's embryo, and you can put that embryo back in the mother, the mouse, and it will form, a new mouse. Frankenmouse. So you can make a mouse with about 10%, which is about 10% rat.
And does it end up...
And this is pretty incredible as well.
That's amazing.
Because this is...
How far away species-wise do they have to be? Do they have to be presumably reasonably related?
Well, we don't know at the moment. Right. So this is a very new technology, very new indeed. So these rat-mouse chimeras have only been around for the past few years, not very long.
Wow.
Essentially, but this is some really interesting stuff, right?
Yeah, go on then.
So...
You're teasing me, Nick. Come on.
For instance, so rats and mice... When you look at these mice that form, that are 10% rat, you can find the rat...
They look like mice?
They look just like mice.
So you wouldn't know any different?
No, this is an interesting question. So they don't appear to have phenotypes which look like rats.
Ooh.
So they to all it...
So does this mean you could be 10% pig and we wouldn't know, Nick?
Wait for it.
Oh, good!
So these mice are 10% rat cells. So if you slice them and you look at the tissues, you can find loads of rat cells interspersed.
So if you took like an antibody that was specific to a rat type.
You don't even need to do that.
Really?
You make the rat cells fluorescent first. So you
fine.
engineer a marker.
Right.
So when you come to look at them...
Any fluorescent stuff is the rat.
Yeah, so they glow. So you can tell them apart by the rat cells glow and the mouse cells don't. Or you can make them both glow, but in different colours.
Yeah,
so one's green and one's red.
Yeah.
Amazing sorts of technical advances. But anyway, but one interesting thing is there's differences, species differences. So rats and mice are quite divergent. Mm-hmm. Several million years separate them.
Yeah.
A couple of million years of evolution separate them at their branch point.
Yeah. Are they further apart than we are to orangutans?
I'm not quite sure of the...
Right, okay.
Probably similar, but I don't know.
Okay.
Anyway, rats don't have a gallbladder.
Do they not?
No, they don't. They don't have a gallbladder. Mice have a gallbladder.
Right.
When they looked at the gallbladder of these mouse-rat hybrids, many of the cells in the gallbladder were derived from the rat. So it's almost like...
It's going back in time.
The rats...
We could make a dinosaur.
It's weird, isn't it? So basically, the rat cells...
Let me get my head around it. So they don't normally have a gallbladder, but the cells that are in the bit of the mouse where the gallbladder is are rat cells.
No, in the mouse that forms,
the
gallbladder is made partially from rat cells.
Yeah, that's what I said.
Oh, was it? Yeah. Okay, I didn't follow.
Okay.
Anyway, so the essentially, even though the rat doesn't normally make a gallbladder, when those cells are present in a mouse, they can retain somewhere in their kind of like backstory. There's a little paragraph which explains how to make a gallbladder, but normally it's kind of disposed of.
Turned off, yeah.
Yeah, it's kind of like vestigial, or you don't form it. But when those cells are in the kind of context of a mouse, it's almost like, oh yeah, we'll read that paragraph and we'll make a gallbladder.
That is nuts.
It's crazy. And what's more, what they could do is...
So is that suggesting there's a gene to make a gallbladder in a rat that's not
active? Yeah.
So it's there, but it's just says to switch that bad boy off. We don't need him normally in a rat.
Yeah.
Wow.
So why is this interesting in terms of human transplantation? I'll tell you why. Another thing you can do in the mouse is you can remove a gene, which is like a master gene, which controls the formation of an organ. In the pancreas, there's a gene called, doesn't matter what it's called PDX1.
Yeah.
All right, which is a kind of master gene for controlling pancreatic development. Now, you can make a mouse which doesn't have that gene. So the pancreas doesn't work, and the mouse dies at around birth or shortly after.
Right.
All right. Now what you can do, you can get the rat cells, you can inject normal rat cells into that mouse that lack that master gene for making the pancreas.
Yeah.
And the mouse will survive, and it will grow a pancreas,
A rat
which
pancreas.
is a rat pancreas. So you can grow a rat pancreas,
But wholly
inside-
rat. But wholly a rat.
pretty much.
Wow.
Not wholly. Some of the specific cell types in the blood and things like
Yeah.
that are derived from the host. But predominantly speaking, because if you remove it, the mouse doesn't have a pancreas, you
Yeah.
know that the rat has saved that mouse. So the rat cells are making the pancreas.
Wow.
Why is that important? Well, it paves the way, maybe.
So that means I can just keep drinking. That's what you're saying. I can just drink hard.
No,
and
no.
worry
Not
about
yet.
that in the future.
Not yet.
Oh,
There's a
damn
number
it.
of problems. So in this paper, this was a paper published in Cell last week. This
Yeah.
technique's been done before. There was a paper published in Nature at the same time, and in the Nature publication, they did just that. They made another species pancreas I think they made a mouse pancreas in a rat, and then they took that pancreas and they cured diabetes. So they used another species as an incubator for a pancreas to save the other species. Now, in the Cell paper, what they did, they thought, well, hang on a minute, could we do this with people?
No.
Could we do it with people? You know what they did?
No, they didn't.
They got human embryonic stem cells, or they're called induced pluripotent cells,
Yeah.
but it doesn't matter. For all intents and purposes, they're early embryonic cells. They took those, and you know what they tried to do?
Was it in a mouse?
No, they didn't waz it in a mouse because they thought, well, a mouse is pretty small. We want
Waz
to
it in
try
a
and
pig?
make it. They wazzed it in a cow and in a pig. So cows are great.
How would you get
cows are great?
ethical-
Cow. I don't know. It was.
That, I mean, I'm just
They
speaking
didn't-
generally. Those
they-
kind of experiments are so difficult to get approved ethically, aren't they? When you go anywhere near humans in any capacity.
Absolutely.
Yeah.
So,
So-
as in the cows, it didn't work. Right, I'll tell you that from the off.
Right.
Didn't contribute at all. So they looked at very early stages of development. They didn't look at a fully grown cow. They looked at very, very early embryos.
So the cow's not walking about or living
No.
or whatever.
But it didn't work in the cow. In the pig, it did work. So they
fuck.
introduced. So again, they removed.
That's the future, Nick.
They were able to find something like 1 in 10 to 100,000 cells in the pig embryo were human derived. So imagine you could take a pig, you could remove a master gene for, let's say, a heart,
Yeah. Liver.
Okay.
Whatever. Yeah.
liver. So they've done all this in the rat mouse thing. They've done it for liver.
Yeah.
They did it for pancreas. They did it for heart. Heart was unsuccessful.
Grow a new human heart in a pig.
Maybe.
Holy
But
shit!
it doesn't at the moment. The rat mouse system, you can do
works
it
well.
really, really well. Human pig, no, it's not working very well. Obviously needs refinement. But is there any reason you couldn't do it in a monkey? Could you make a human liver in a monkey? Quite closely related species.
And these cells that they're induced pluripotent stem cells.
Yeah.
Okay.
But
So
they also they actually used a
do
variety
they
of
regress?
pluripotent
Okay,
cells.
okay.
So you can use, and this is a little bit more of a technical area.
Yeah.
But there are lots of different stages of embryonic stem cells now.
Yeah.
Some are called naive, some are primed.
Mm-hmm.
So there's a spectrum, continuous spectrum, and there's several different methods you can use to look at them all. Induced pluripotent cells they also tried as well. So that's when you regress a skin cell to behave like an embryonic cell. But basically, maybe in the future there'll be a pig walking around with a human brain.
That is the stuff.
A human brain
that's
pig.
Hello,
Steve.
Super pig.
Would you like some bacon, Steve? If you like in Hitchhiker's Guide to the Galaxy. Hello, Steve. I don't want a bit of bacon today.
It does. I like the way. I like his accent as
Yeah,
well.
it's kind of like a South European pig.
And a little bit like Papa Lazarou as well. Hello, Steve.
Yum, ma'am. Anyway.
But like it's the stuff of science fiction, right? I mean,
yes,
really,
it's the stuff of science fiction.
it
You're
really
quite
does.
right, yes.
It's I mean, that's incredible. Those type of things normally. So normally, if there's not, when people say stuff like that, you normally, as a scientist, you kind of have to like laugh it off and pretend they're not massive idiots. When someone says, "Well, can't we do that?" That really is, right? That's one of those things that really throws up some really ethical issues, right?
So I don't know what the ethical situation... So I know with embryonic cells, with human embryonic cells, you can take an embryo and you can grow it up to 14 days post-fertilization.
And that's the time and then you terminate
then you have to kill the embryo. You can't work beyond 14 days.
Because that's for ethical reasons.
It's the HFEA
something.
Yeah, they've come up with they come up with it's a quango, but it's a very good body that there's lots of political debate around it and they settle on things.
Yeah,
they're trying to push it to 28 days at the moment. So there've been a number of different approaches.
So
to try and extend
on the super pig, on the human pig hybrid, how far along was the embryo before they terminated it?
I don't know, Steve.
Right,
I have to come back to it.
That's exciting. That's wow. But maybe we'll return to super pig when the new paper comes out.
Yeah, absolutely.
Do you reckon they like us calling it super pig?
I don't know.
Or
I tell you what, it brings a whole new context to Babe the Sheep Pig, doesn't it?
That'll do, pig.
Is there a scientist edition of Top Trumps?
No, but maybe we should make one.
What if we do one?
That'd
we
be
could
fun.
propose it to Top Trumps.
So I think so. Who would you have? And the big guns, obviously, we've got Isaac Newton. We've got Einstein. You got to have Dirac.
James Clerk Maxwell.
Absolutely.
Michael Faraday.
Rutherford.
We're all physicists so far. Charles Darwin.
Well, no, it's before there was real
Charles
division.
Darwin. James Watson. Gregor Mendel. Could you have Crick as well? Or would you have one for all of them? You'd have to have Franklin, because otherwise you'd be sexist.
Yeah, or Madame Curie, definitely you'd have.
Madame Curie,
yeah,
Marie Curie.
Yeah, she was
well, I suppose so, but I'd never heard of her called Madame Curie.
Yeah, definitely.
Okay,
yeah.
Who's Dr. Curie?
Not Professor or whatever. Yeah,
Dr. Marie Curie.
Yeah,
and then you'd come up with there's a bunch of other famous female
Feynman.
Scientists. Feynman, yeah.
If you had to have
you'd need females though.
There's not that many though, particularly historically.
You'd have to have newbies.
If you had a dinner party, past or present, you got who are you going to have? Scientists.
Hitler.
No. Scientists.
Can't I have Hitler?
No, you can't have. Well, if he's a scientist, you can, but he's not, so you can't. I think you got to have Feynman. Feynman would be awesome, wouldn't he?
Well,
he's going to be a bit of a prick, but he's going to
take over the conversation.
Yeah.
It'd be quite irritating. No, I think I'd have someone who's a bit more humble and softly spoken. I'd have Faraday there.
Faraday, nice.
Faraday, probably Einstein. Dirac wouldn't
just
say
for shits
much,
and giggles.
Apparently,
he was a fair weirdo, wasn't he?
He was quite quiet. Yeah.
There's what's his name? Andrew Wild. He's still alive.
Don't know who he is.
So he solved Fermat's last theorem. Took him 8 years.
I didn't think anyone solved that.
Yep, he did.
Is he the one who just wanted to hide away and
7 years? He just hung out in his house.
He didn't want to be.
Yeah.
Yeah.
So that was a very famous mathematical proof that's evaded mathematicians for something like 200 years or 300 years or something, and he figured it out.
ScienceShed! We're in the ScienceShed! ScienceShed! We're in the ScienceShed! Come on, Steve!
Bunsen.
Burner!
Dolly.
Machine!
Internal.
Combustion!
Why do we need
Steam!
Petri?
Dishes!
Oscar.
Base!
Isaac.
Newton!
Transplanting.
Science!
Right, boys, I enjoyed that podcast. That was pretty good, mate. Enjoyed it. Enjoyed hearing about the pigs with the bloody organ crap going on. That's crazy shit, man.
Well, I'm glad you enjoyed it, Bruce. If you like the Science Shed and want to hear more, the best thing to do is to get in touch with us on social media.
What's social media, mate? I don't understand.
It's kind of like the pub, but online.
A load of blokes talking to each other, drinking beers and like having a good time in there.
That's pretty much right. Yeah.
Great, bonza, mate.
Yes, you can get in touch with me. I'm Steve the Chemist on Twitter, and Nick is the Evans Lab. I
like you, Steve. I'm not sure about that other guy. Seems a bit of a fool to me, mate.
He is a bit of a fool, isn't he?
Yeah.
The other thing you can do is if you really like the Science Shed and you want other people in Australia to enjoy it as much as you just have done, Bruce, if you could leave us a review on iTunes, that would be great.
Fair income, mate. I'll do that. No worries.